Have you ever wondered if life could exist in the harshest and most extreme environments of the cosmos? This question is the driving force behind a fascinating field of study known as astrobiology. Astrobiology is not just about the search for extraterrestrial life. It's a quest to understand the very nature of life itself, its origins, its evolution, and its future. It's about exploring the limits of life, asking how far can life adapt? Can it thrive under conditions that we, humans, would find inhospitable or even deadly? The cosmos is vast and mysterious, filled with galaxies, stars, and planets, each with their unique conditions. Some of these celestial bodies harbor extreme environments, from the scorching heat of stars to the freezing cold of outer space, from the crushing gravity of black holes to the chaotic storms of gas giants. Yet, life, as tenacious and adaptable as it is, might find a way. Astrobiology is an interdisciplinary science combining elements of biology, chemistry, physics, and astronomy, among others. It's a testament to human curiosity, our desire to reach out into the unknown, to seek answers to our most profound questions. Are we alone in the universe? Is Earth unique in its ability to support life? Life on Earth is diverse, resilient, and often surprising in its ability to adapt. We've found life in the deepest trenches of our oceans and the highest peaks of our mountains. We've discovered organisms that can survive in boiling hot springs and the frozen tundra. If life can exist in such extreme conditions here on Earth, why not elsewhere in the cosmos? Astrobiology, a bridge between the stars and life, has a fascinating history, and it all began with a single question. It's a new era of exploration, an adventure into the vast cosmic ocean, guided by our thirst for knowledge and our hope to find companions in the immensity of the universe. When did we first start asking if life could exist beyond Earth? This question has haunted humanity for centuries, but it wasn't until the latter half of the 20th century that we began to explore it scientifically. This marked the inception of astrobiology, a field that combines biology, astronomy, and geology to investigate the possibility of life beyond our planet. The dawn of astrobiology was sparked by a handful of visionaries who dared to look up at the stars and wonder. Among them was Joshua Lederberg, a Nobel laureate in physiology or medicine, who in the 1960s coined the term exobiology, the precursor to today's astrobiology. His work set the stage for a new field of study, one that dared to ask whether we are alone in the universe. Another key figure was Carl Sagan, an astronomer and a masterful science communicator. He not only brought the idea of extraterrestrial life into the public eye, but also pioneered the concept of panspermia, the idea that life could travel between planets, potentially seeding life across the cosmos. The field also owes much to the discovery of extremophiles, organisms that thrive in environments once thought inhospitable to life. These extremophiles, discovered in the late 20th century, expanded our understanding of where life could exist, opening up possibilities for life on other planets. Astrobiology also brought with it a shift in perspective. No longer were we looking at the universe as a collection of isolated bodies, but instead as a network of potential habitats, each with its own potential for hosting life. This concept, known as habitability, has become a cornerstone of astrobiology, guiding our search for life beyond Earth. The dawn of astrobiology marked the beginning of a new era of exploration and discovery. It's a field that continues to push the boundaries of our knowledge, challenging our understanding of life and its place in the universe. As we continue to explore the cosmos, who knows what we might find? Perhaps we are not alone after all. To find life in the cosmos, we first have to understand life on Earth. It's here, in our own backyard, that we find the biggest clues to determine what might be possible out there in the vast universe. Let's take a moment to consider the basic requirements for life as we know it. First, we need a source of energy. For most life forms on Earth, that energy comes from the sun, but not all life relies on sunlight. Deep in the ocean's abyss, where sunlight cannot reach, organisms thrive around hydrothermal vents, drawing energy from the Earth's inner heat. Water is another essential ingredient for life. It's the universal solvent, facilitating the chemistry of life. From the deepest trenches of the oceans to the driest deserts, where life seems impossible, water, in one form or another, is present. And let's not forget about the building blocks of life: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. These 6 elements form the basis of all known organisms on Earth, from the smallest microbe to the largest whale. In our quest to understand life, we've discovered an astonishing diversity of life forms on our planet, especially in extreme environments. Microorganisms known as extremophiles thrive in conditions that would be deadly to most life forms. They survive in scorching heat, freezing cold, extreme pressure, and even in the vacuum of space. Such organisms challenge our traditional notions of where and how life can exist. They expand our understanding of life's potential, showing us that life is not only resilient but also adaptable. If life can endure Earth's harshest environments, then why not somewhere else in the cosmos? The study of life on Earth, in its myriad forms and in its most extreme habitats, is not just a journey of understanding our own existence. It is also a beacon illuminating possibilities of what could be lurking in the cosmic shadows. Understanding life on Earth sets the stage for our search for life in the cosmos. As we gaze up at the stars, we are not just looking for signs of life as we know it. We are looking for the unknown, the unexpected, and the unimaginable. The search continues, fueled by the resilience and adaptability of life on our own planet. Life on Earth thrives in places you wouldn't expect. From the deepest depths of the ocean to the frigid expanses of the Antarctic, life has a remarkable way of adapting to incredibly harsh conditions. Let's take a journey to the bottom of the ocean, to the hydrothermal vents where sunlight is a foreign concept. Yet life exists here in abundance. These vents spew out superheated water packed with minerals, creating an environment that would be lethal to most life forms. But not for the extremophiles that call this place home. These organisms, like tube worms and certain types of bacteria, have evolved to not only survive, but to thrive in this heated, high-pressure environment. Now let's travel to the other extreme, to the coldest place on Earth, Antarctica. Here, temperatures can plummet to below 80 degrees Celsius, a temperature so cold that it can freeze exposed skin in a matter of minutes. Yet life persists. Microorganisms, like the Antarctic midge, the only insect native to the continent, have adapted to survive in these freezing conditions. They can withstand dehydration, UV radiation, and extreme temperatures, proving once again the resilience and adaptability of life. But it's not just the freezing cold and the heated depths where life thrives. The Atacama Desert in Chile, one of the driest places on Earth, also hosts life. Certain bacteria and fungi have adapted to the extreme aridity and high UV radiation, living in the soil and on the rocks. These examples illustrate the incredible resilience and adaptability of life. Life finds a way to survive and thrive even in the most extreme conditions. It molds itself, evolves, and adapts, demonstrating a tenacity that is truly awe-inspiring. So as we gaze into the cosmos, we can't help but wonder, if life can thrive in Earth's harshest environments, could it exist in the cosmos? The search for life beyond our blue planet is fueled by the remarkable resilience of life here on Earth. The possibilities are as vast as the universe itself. Our search for life begins in our very own backyard, the solar system. As we cast our gaze across the cosmos, we begin our quest for life closer to home. Our solar system, a fascinating cosmic neighborhood, harbors celestial bodies that could potentially harbor life. In this cosmic dance, 3 celestial bodies stand out: Mars, Europa, and Enceladus. First, let's turn our attention to Mars, the red planet. With its vast valleys, towering volcanoes, and potential for liquid water in the past, Mars has always been a prime candidate in our search for life. Scientists have uncovered evidence of ancient riverbeds and potentially habitable environments. Could it be that Mars once hosted life? Or perhaps, in its subsurface, still does? The rovers and orbiters we've dispatched to Mars continue to seek answers to these tantalizing questions. Next, we journey to Jupiter's moon, Europa. Beneath its icy surface lies a vast, salty ocean containing twice the volume of all Earth's oceans combined. This makes Europa a compelling place to search for life. Could organisms akin to extremophiles on Earth thrive in such an ocean, warmed by the tidal forces of Jupiter's immense gravity? Lastly, we visit Saturn's moon, Enceladus. This icy world spews plumes of water vapor from its surface, suggesting a subsurface ocean warmed by geological activity. These plumes contain organic compounds, the building blocks of life. Could these seas be teeming with life, as some of Earth's deep-sea vents are? Our search for life in the solar system is a testament to human curiosity and our quest to understand our place in the cosmos. Each mission, each discovery, brings us one step closer to answering the question that has fascinated us for centuries. Are we alone in the universe? The solar system is just the start. The cosmos is vast and full of possibilities. Beyond our solar system, countless worlds await. These mysterious celestial bodies, known as exoplanets, orbit stars far beyond our own sun. The discovery of these distant worlds has completely transformed our understanding of the universe and breathed new life into the search for extraterrestrial life forms. In the grand theatre of the cosmos, our technology has allowed us to detect over 4,000 exoplanets to date. Each one is a potential stage for the drama of life to unfold. But where should we look? What are the conditions necessary for life as we understand it to exist? Enter the concept of the habitable zone, often referred to as the Goldilocks zone. Just like in the fairy tale, this is the region around a star where conditions are just right, not too hot, not too cold, for liquid water to exist on the surface of a planet. Water, as we know it, is a key ingredient for life. Therefore, planets within this zone have the potential to host life. But here's the twist. Life as we know it is just one possibility. The universe is vast and diverse, and so too could be the forms of life it harbors. Astrobiology is expanding its search parameters, looking at planets with extreme conditions where extremophile life forms might exist. These are organisms that thrive in conditions harsh to most known life forms, conditions that may be commonplace on distant exoplanets. The study of exoplanets is like piecing together a cosmic jigsaw puzzle. Each discovery adds another piece to the picture, bringing us one step closer to answering the age-old question: are we alone in the universe? Exoplanets offer a tantalizing possibility. Could one of these worlds harbor life? As we continue our cosmic journey of discovery, only time and science will tell. Astrobiology is a rapidly evolving field. Let's catch up with the latest. In the past few years, there have been groundbreaking discoveries that have set the scientific community abuzz with excitement. One of the most intriguing findings took place in our very own solar system, on Venus, our neighboring planet often referred to as Earth's evil twin. Scientists discovered phosphine gas in Venus's clouds, a potential biosignature, hinting at possible microbial life. While phosphine can be produced by non-biological processes, the quantity detected on Venus was so high that it left researchers scratching their heads, considering the possibility of life forms resilient enough to survive in the planet's harsh, acidic atmosphere. But of course, more research is needed to confirm this exciting prospect. Moving on from Venus, let's swing by Mars, the red planet. Mars has long intrigued us with its potential for harboring life. Recently, the Mars rover missions have provided us with valuable data, leading to the detection of organic molecules. These molecules, while not direct evidence of life, are the building blocks of life as we know it. The discovery of these molecules in Mars's soil suggests that the planet may have once been suitable for life, and it could potentially still harbor life beneath its surface. These exploratory missions to Venus and Mars are not just about looking for signs of life. They also offer valuable insights into the conditions that can support life in extreme environments. The knowledge gained from these missions could help us understand how life might arise and survive on other, more distant worlds. In the grand scheme of things, these discoveries might seem small, but each one of them adds a piece to the vast puzzle we're trying to solve in our quest to understand the universe and our place within it. They fuel our curiosity and inspire us to keep exploring, to keep pushing the boundaries of what we know. These discoveries bring us one step closer to answering the question: are we alone in the universe? What does the future hold for astrobiology? A question that sparks the imagination, and one that has no simple answer. As we look ahead, we see a future filled with exciting opportunities and novel technologies that promise to advance our search for life beyond Earth. Astrobiology is a field that is continuously evolving. In the coming years, we will see a wave of new missions launched to explore the farthest reaches of our solar system. From the icy moons of Jupiter and Saturn, where under-ice oceans may harbor life, to Mars, where the search for microbial life is ongoing, these missions will push the boundaries of what we know about life's potential in the universe. The future also holds promise for advancements in technology. The development of more sophisticated telescopes will allow us to peer deeper into the cosmos, perhaps even allowing us to detect signs of life on distant exoplanets. Additionally, advances in robotics and artificial intelligence will play a crucial role in exploring remote and harsh environments where humans cannot easily reach. But perhaps most importantly, the future of astrobiology lies in interdisciplinary research. Astrobiology is not a field that can be approached from a single perspective. It requires the collaboration of biologists, astronomers, geologists, chemists, and many other specialists. It's this fusion of knowledge that will drive the field forward, helping us to understand the complex interactions between life and its environment, whether on Earth or on a distant exoplanet. Looking ahead, we can expect that our understanding of life in the universe will continue to grow and evolve. Each new discovery, each new mission, each new technological advancement brings us one step closer to answering the age-old question, are we alone in the universe? The future of astrobiology is bright, and every discovery brings us closer to understanding our place in the cosmos. So, what have we learned about life in extreme cosmic environments? We've journeyed from the dawn of astrobiology, a field that has redefined our understanding of life's potential. We've considered life as we know it, which has challenged us to rethink our definitions, to expand our horizons about where and how life can exist. We've delved into life in extreme environments, from the scorching heat of hydrothermal vents to the icy depths of subglacial lakes. These hostile conditions on Earth have given us a glimpse into the resilience of life, showing us that it can thrive even in the most challenging conditions. We've looked beyond our solar system and ventured into the realm of exoplanets, exploring the tantalizing possibilities of life existing in worlds vastly different from our own. Each new discovery, each new planet, broadens our understanding and brings us a step closer to answering one of humanity's most profound questions: are we alone in the universe? We've shared the latest discoveries in astrobiology, from tantalizing traces of water on Mars to the detection of organic molecules on distant exoplanets. Each of these findings fuels the fires of curiosity, driving us further in our quest to uncover life's cosmic origins. And we've peered into the future of astrobiology, a future filled with promise and potential. With every new mission, with every new discovery, we inch closer to finding the answers we seek. We stand on the brink of a new era of exploration, an era that may well reveal the existence of life beyond our home planet. In our exploration of life in extreme cosmic environments, we've learned that life is tenacious, adaptable, and incredibly resilient. It pushes boundaries, it defies expectations, and it surprises us at every turn. As we continue to explore the cosmos, we carry with us the hope of finding life in the most unexpected of places.